Welcome to Qamar MoonBoy channel and subscribe my channel by clicking on this red subscribe button and click on this bell icon to be updated with my latest videos every time I upload it. Welcome to Qamar MoonBoy channel, and this is Sheikh Qamaruddin, your host, and I will be teaching you ETABS 2016. And from the last video, you might have seen that we have completed up to constructing a slab panel in the plan, which we have drawn from the CAD file by importing a CAD file. And Kishore is with me, and Kishore, uh, now next thing, can you show me the openings and column positions?
Hi sir.
Yes,
Hello.
hi.
Hi sir. I I'm showing that sir. These are the column positions and the openings of these plans.
So now we will define this opening first, then we will position the columns, as we have decided that the corner or the outside columns we will keep it as 750 by 750, and inside columns we will define it as 900 by 900. And if that fails, again we have to change the column after the design. Okay, so
Sir, these three are lifts sir. This one also fire lift sir. These two are fully open.
okay, these two are fully open,
Yes sir.
and these three and that one is fourth one is nothing but these are lifts, right?
Lift, and this is fire lift sir. Emergency lift.
Emergency lift. Okay, one is emergency lift,
Yeah.
and these three are lifts. Okay,
Yeah.
so let us minimize and create this opening. Okay,
Okay.
yeah, do minimize. Yeah, so we can just go to this opening, create slab, rectangular slab we will take. In this we will select the opening.
Okay.
So it is not holding the joint, you can see, right?
Yeah.
So I want to hold this intersection joint actually. So what we will do is we'll just undo this, and here we have to select similar stories, and again go back to the draw mode. Here snap options are there. In this snap options we can select here joints are selected, lines, line ends and midpoints, intersection,
Okay.
and we have some lines and frames, edges. So based on our drawing requirements, every time we should change this snap points so that it is easy for us to create the structure according to the plan.
Okay sir.
Apply and close. Now we will again go for the drawing that opening. Now it will hold the points properly. See, it is showing the intersection point. Also it has been drawn for all the floors, you can see now, right?
Alright.
Yeah, now similarly we will do for this side. Okay,
Okay. Sir, instead of creating opening, if we delete this slab, it also considers opening only sir.
yes, if you draw the slab, or we if we create a certain, okay, This slab is totally one slab. If you select the slab, it will be showing one shell selected. That means this slab is totally connected together. Okay.
Okay, sir.
So if you can, if you want to create separate slabs, then you have to create one by one.
Okay, sir.
Then you can keep the place open, left for the slab. Okay, some places you can left without creating the slab, so that will be same as opening. Done. So all the openings we have completed, right?
Yeah.
So go out of the draw menu. Now here you said we have, okay, we have some lift points. So lift points, you are providing the shear wall, right? Concrete wall or just
Yes,
brick
sir.
wall?
She- Shear wall only, sir.
Shear wall only. So we'll provide shear wall with lift opening on this side, right? On this side, right?
Okay. Yeah.
This lift will be having opening this side. This will be having this side.
Yes, sir.
This will be having this side, and this one will be having this side, I think.
Yes.
Oh, one more thing. Before giving the column, we have to extend the slab positions. Slab. So I have to select the slab. The total slab is got selected. Now I have to go to edit shell, and then we have to expand the shells. We will expand the shell by we are doing 750 by 750 column, right? Exterior columns.
Yes, sir.
So half of 750 will be, it's 375,
Sir. 750, sir.
750,
325.
375.
375.
Yeah, so we will provide 375 or 400. So 375 extra we will provide outside offset value. Then it will be applied. Okay. Now you can see that the flat slab is 375 mm more than the grid
Yes,
central
sir.
line. Okay. Now from this corner we will start drawing the outside columns. For drawing the columns we will select here all stories. Then we'll select the quick draw column, and 750 by 750 column here, it is continuous, and we are holding the middle center, means we are holding the center point like this. Okay, so start clicking one by one like this. plan, we will go to the bottom floor footing level, and we will make all the footings as fixed. Now if I go to 3D, yeah, now it is correct. Now we'll select the beams, select object type, beams, select, close. We'll zoom it quite a bit. We will go to view, show selected objects only. On the similar stories, go to plan, apply, close, select, all the beams, go to 3D again. See that plinth beams are not selected now. Okay, all the beams we will delete other than plinth beams. Go to deselect and deselect the joints, deselect the joints, close. Now we will delete the beams. Go to edit, delete, beams got deleted. Okay, now we will go to view, show all objects. Now these are flat slabs with columns. At the bottom it is plinth beams and fixed footings. Now we need to draw the walls, right? So for that we need to define some walls. We will go to the plan and we will go to the plinth level. We will zoom it. We'll provide lifts, 3 lifts, here, here and here, with opening this side. For that we have to go to define, but again opening we have to keep that. If we take directly wall stacks now, opening also will be coming properly directly with one click. So we'll modify the wall property. We'll select it as M35 wall, M35 wall. We'll give it as wall thickness 200 we will give. Okay, it is shell thin, everything is okay, done. Also, if you want to design the walls, we need to give the walls modifiers as we can give shear modifiers 0.75, not 0.75, 0.7 only, same as column. Yeah, I can't hear you. What you say?
Why are you changing, sir? What is the reason?
That will give us the actual design of concrete, because these are concrete walls, right?
The, that is specified in code book, sir.
Yes, yes, it is specified as per, okay, design. To design walls, we need to give, if the wall is just a shear wall, or just it is not taking any, okay, it is not taking any lateral load, then it is we have to take it as 0.7. It is acting, if it is acting as a column, in position of column like shear wall. If otherwise, we have to take it as 0.25 as we take for slabs. For that also we will create one video. Okay, let us just start drawing the walls. Properties wall 1, wall 200. It is a pier, offset is no, straight line. Okay,
Sir, we draw only for one story, sir. Then we repeat it. Otherwise, we have to draw all openings. Sorry, all stories.
okay, okay. So we'll draw for one story, right?
Yeah, yeah.
Then also, if you replicate also, the opening size will not be proper. Let us draw for all stories. Just I will try, okay?
Okay.
Just let us try first. Wall pier. Just we will go to select object type, walls, select, close, view, show selected objects only. Let me select this 3D, rotate, F2. It is not done, no? Bottom distance, what it is required?
What is the question?
Let me see this grid. What is this grid line? Grid line is 16, right? In this I will go to elevation and 16. It's not showing. So many 16 are there? this 16. So we have to select like this.
Give left side distance also.
Yeah,
And we'll do that. We have to give left side distance also, then it will automatically take, sir.
left side distance also.
From this edge we have to give this distance.
Yeah. So 1500 out of 2000, 2.2. 2.2. Let me calculate. 2.2 minus 1.5 is 0.7. 0.7 divided 2. 0.35. 350 mm. Is it coming okay? Let us give some. Yeah. Your voice is not audible.
This is 2.06 now, sir. With this.
Width is 2.06.
These two are 2.22.
06 minus 0.1.5 is the opening we are keeping, right?
Yes, sir.
So 0.28, so 280. define some drop panel. Okay, define in slab section, add new property as M25 shell thin as a drop, right?
Okay.
We'll write it as drop. Drop thickness will be, it should be more, it should be more than slab thickness, that is drop plus slab. It will be again it should be 300 plus 120, like that, 325, or you can take, yeah, more than that. Is we have taken slab thickness as 200, right? So it should be it should be more than the half of the depth of the depth below the slab should be more than d by 2. D is nothing but, again, we have 200, so 200 by 2 is 100, so it should be more than 300. So we can keep it as 325 or 350. Let's take 350. Okay, or we can also provide that 400. Let us keep 400 only directly. Double of that, much more is better. What we have to do is we have to see, what we have to do is we have to create some points. We have to create some points here. Then we have to draw a drop panel like this. Everywhere drop panels are not required. I think only in this position it is required. Here and here and here. So we will save up to here. In the next session we will decide the drop panels, and we will create the drop panels in this. Okay, let us give the loading.
Okay, sir.
Dead load, live load, and all this loading. Wall load also we will take with the slab load, so we will it will be a super dead load. So extra wall load, extra slab load will be wall load plus sulfate is already taken, so floor finishes and wall load together. Floor finishes plus wall together, we will take it as a super dead load, and we will add a new load like this. Other than this, we have wind X, it is the wind load. As for Indian code, add new load. Wind Y, add new load, and again we need to modify. We'll modify it later, just to add EQX. Earthquake you are taking, na? Earthquake you are taking in the consideration or not?
That's the response that I'm considering.
Okay, then we have to take EQX as seismic load as IS 1893. EQY done.
Sir, in this IS 875 2015 is there, no sir?
IS
1875 2015 is there for wind loads.
This one?
Yes, sir, this.
Okay.
Modify loads.
Okay, it's there. We have to define the diaphragm.
Okay.
I need to give the diaphragm to all the slabs. Now I can modify the wind loads. What is the wind speed there? Where you are taking this building?
Take 50 only. Hyderabad is the one. 50 only.
Rajmundry or Hyderabad?
Hyderabad only.
So Hyderabad is 44. Terrain category. Importance factor. It's one only. These all things are there in the code book. We need to give in the x direction. So x direction will be 0 and 180 degree to the diaphragm. So it should take all the diaphragm. Yeah?
Sir, in 0 it's not showing the values, why sir?
No, it will not show 0 value.
Sir, what is this option, sir?
Our
This,
plinth level is the
shell option.
Wait. Plinth level is the bottom story level.
Okay.
To the diaphragm one this. Which value? Which value you are asking?
What is the shell option?
Shell objects.
Option, sir, this option. Yeah.
Shell objects option you are telling.
Yeah.
If you draw
that option, sir?
If you draw exterior walls, brick walls, then to that walls directly you can select as a shell objects. If you select that, all these things will go away. Then you have to give in the assign shell loads, you have to give the wind loads as a frame pressure.
Okay.
And you have to give the windward and leeward coefficient, all that thing there. For different shell object, you can give different wind loads.
Okay,
So to the diaphragms you are giving here.
Okay.
Modify for y direction. Seismic zone?
Hyderabad, seismic zone 3, I think.
Yeah. Zone 3?
Yeah.
Reduction factor?
5 only.
3 or 5? 3 or 5?
5.
5 only. Okay. Program calculated?
Sir, once. What is this, sir? These two?
Which two?
Eccentricity is there, no, sir. For what this we have to do?
Eccentricity we have to consider when we are taking some irregular shape of building.
Okay.
30% eccentricity we
Sir,
need to take.
sir, this is irregular only, sir, not regular, no?
Yeah, irregular only. We can take it, but again, for if you take eccentricity, yeah, it will be difficult for you to calculate all the means all the scale factor and all
Okay, okay.
in the response spectrum, because
Okay.
in response spectrum you are not going to consider any eccentricity, right?
Okay, sir. Okay.
We will be having response spectrum x direction and y direction, two direction. Then if you take
Okay, sir.
eccentricity
Okay.
again, you have to provide that eccentricity ratio for all the diaphragms.
Oh, oh, okay, sir. Okay.
Then if you know the time period already, you can provide it user defined time period, your time
Okay.
in the time period. Otherwise the program will calculate it, because we have given the story range from bottom to top. It will take the program calculated calculation will be okay. For zone 3 plinth level, done
Okay,
up
sir.
to here. Now we can select the slab, assign some shell loading, floor finishes plus wall load 5 we can give. To the total slab
Have
it
you
has taken.
taken 5, sir?
Yeah,
Sir? Have you taken 5, sir?
I am taking a 1.5 1.5 as a floor finishes, 1.5 as a fall ceiling and all. Then I am taking the wall load as totally 2 kilonewton distributed per meter square. I can provide
Okay, sir.
anywhere walls. Okay,
Okay.
now select again, assign the live load. So residential means it is 2,
Okay.
commercial it is 3 or
Residential
4.
only.
So we'll take 2.5 or 2.
Okay. Okay, sir. No problem. 2.5.
2.5 because in the corridors again we will have to take,
Okay.
right?
Okay.
So loads are given, right?
Okay. Okay.
Combinations are added. One more thing, dead load one time, wall loads one time, and live load 0.25 times, right? Model cases modify. Number of modes, maximum number of modes should be taken as such to obtain the maximum the sum of the
That I know, sir. How
deflection
did you take in 30, sir? That
should be more than 90%. Now it should be more than 90%.
yes, sir.
Yeah, that if it is more than 90%, so mode shapes actually for one floor or one story, it has 6 degrees of freedom.
Yeah.
So in this actually one direction is restricted, that is Z direction, so we can neglect 2, so 4 degrees of freedom we can take for each story. If it is 4, okay, then
Okay.
for 20 stories it will be
80.
80. So
Yes.
minimum I am taking some let us take 2 or 1, just if I consider 1 also, it will be 20 or 12 plus 1 21, it will be, because plinth level also we have taken, so
Okay.
21. So I am taking approximately 30, because I don't think in 20 mode shapes it will become 90%. That's why minimum, from minimum we should go on with multiples of 3.
Okay.
So we start from 12 as the program has given, but we'll take 12, then 15, then like that. So that modes are not sufficient, so I am taking
Okay.
directly 30. If the modes are sufficient, then it is okay, then otherwise we have to again increase the mode shapes.
Okay.
Wall design we are not doing, no.
Yes, sir. Sir, we didn't mention the function, no, sir. Function.
Response spectrum function, that we will
Yeah.
do later. First the building should be
Okay.
safe. We have to see that whether the slabs are getting more deflection or less deflection. Three deflection. So the deflection are allowed under control. Let us see for the combination, collapse combination.
Sir, how much
Decontour.
deflection allowed, sir? Up to?
Deflection is allowed
Yes, sir.
up to span by 250 span by 250 and it should be less than 20 mm.
Bending moment, sir.
Depending on that, bending moment will be coming, no? If I see from the plan, fourteen mm, 12 mm. Okay, we have this diagram, deflection diagram, we have the bending moment diagram. Let us see. So we have this bending moment diagram, and also we have the, here we can see the wind forces. This one. These are the earthquake forces, how it is acting, how much is the value. These are wind forces.
Values are not there, no, sir.
This is the value. If you take the cursor there,
Okay,
it will be
sir.
value. If you want
Okay.
to see in form of a table, here it is detailed report. It will be having the values at each story. It will be having. See, these are the values. For wind X means again these are the values. These are the values. Take earthquake. These are the values. Okay. So okay, we will end up here.
Okay, sir.
Okay, thank you for watching this video and making up to the end. Please share, like and subscribe this channel for more videos like this. Thank you. Bye bye.
Thank you, sir.